we are very much involved in green energy concepts and green energy production, including enable technologies for green energy. So the talk that I'm going to give today is on production of fuel, which is based on green technology. So basically it's on biodiesel from algae. So first of all, I'd like to just highlight some of the terminologies. When we say green technology, what does it mean is referring to sustainable and non-toxic production and production methods. Okay, so it must be sustainable and non-toxic. So, and then application of environmental friendly technology to conserve natural resources and the environment. So that is sustainable development. So basically what we want to look is at sustainable development. Whatever resources that we have to use it in a manner that we can replenish it. So if the resources finishes, then it is not sustainable. And whatever we produce has to be able to recycle. So that is basically sustainable development. So renewable energy and alternative uses are the heart of green technology. So when we talk about renewable energy, we talk about green technology. So the goals in green technology, number one, sustainability. Number two, cradle to cradle design. That means it has to be a complete cycle. It has to start from somewhere, go back and back to the nature again. Source reduction, that means we must cut down on the materials that we use to produce it. Pollution reduction and byproducts reduction. And of course, we must have innovative technologies that uses less energy, less material, and less production of waste. So this is basically the goals of a green technology. And areas of interest in green technology, obviously the first one is energy. That is the main thrust of green technology. So a lot of efforts are being put in to use green technology for power generation. Then we have also green technology in buildings, okay, green buildings. Then green chemistry, okay, green technology being applied in chemical reactions, productions of products, and green nanotechnology. So these are areas of green technology. We will focus on energy, okay, the energy part. So when we look at the energy, the principles of green chemistry is important. So these are some of the basic principles that we want to use whenever we are producing green energy. That is, we want to have waste reduction, we want to use raw materials which are renewable, okay, that means you can replenish it. We want to employ catalysts so that the reaction is fast. We want to avoid chemical derivatives, we want to use non-toxic chemicals. We want to maximize atom economy, okay, we use tiny atoms. We want to reduce solvents, okay, we don't have too much solvents. Energy efficiency, we must use less energy for the production, and real-time monitoring and other environmental considerations. So this is the concept in the green chemistry, which is also part of the green energy production. This is a scenario of Malaysian power generation now. This is obtained from TNB. So you can see that majority of our power generated by TNB uses gas, which is almost 50%, coal 26%, oil 12%, hydro 12%, and renewable is only 1%. Very, very, very low. Okay? So majority of the fuel that we use is known as fossil fuel. Gas, coal, and oil. These are known as fossil fuel. They are non-renewable. Okay? And this power that is generated using these things are used up in majority, if you can see there, in the industry about 45% uses the power from TNB, commercial 34%, residential 20%, and others 1.7%. So chunk of the power generated is actually used up by industries and followed by commercial entities. So the problem that we have now is majority of our energy is produced by fossil fuel. And this fossil fuel, of course, cause problems. As you can see, air pollution, environmental pollution, global warming because of CO2 emission, and dependence, economic dependence, because we have to depend on foreign import for our energy. And if you are aware that recently, as recent as last week, I think the fuel price was increased by 20 cents. Everybody is not happy with that. And don't be surprised that the TNB is going to increase their tariff by 1st Jan 2015. Don't quote me, but that's the information that I gather. So fuel price is going to go up because we don't have enough of these materials. So like it or not, we have to look for new resources. It has to be renewable so that we can use our indigenous products and produce energy. So fossil fuel, the biggest problem with fossil fuel, of course, one is economic. The other one is CO2 emission. CO2 emission is very high from the fossil fuel, and this causes global warming. And if you remember, 4 years ago, our Prime Minister had kind of ratified a treaty at Kyoto saying that we are going to reduce CO2 emission by 40%. I don't know where we are now, but that was the promise made, but I don't know what will happen. By 2020, we are supposed to reduce the CO2 emission by 40%. Okay, so because of this global warming, and the biggest culprit for the global warming is the CO2. So what we can do to reduce this CO2 is reduce the use of fossil fuels. That's number one. We must remove CO2 from the atmosphere. So whatever CO2 is emitted, we try to remove it from the atmosphere. There are ways we can use to remove it. And the third one is capturing and sequestering or utilizing CO2 emitted by the fossil before it enters the atmosphere. So that means when you produce the CO2 from the exhaust, immediately utilize it for something else. So these are the three things that we can do to reduce the CO2. Okay. And these are the major source of renewable energy that we have. Some of it is available in Malaysia, some is not. We have mini hydro. Mini hydro is renewable. The big hydro is non-renewable. Okay. The definition is mini hydro is renewable. The big hydro is non-renewable. Wind, solar, these are all renewable. Biomass, we have plenty of biomass from the palm oil industry. So that is the energy. Tidal energy from the sea waves. Geothermal from the ground, steam. Wave, biofuel, that's what we are going to look at later on. This is the fuel that is derived from biomass. Okay. This fuel is very similar to diesel, but it is not from the fossil, but it is from natural bioproducts and biogas. Okay, so this is another one. So these are the major one. And in Malaysia, at the moment, because of a very big palm oil industry that we have, so we have a lot of biomass from the palm oil waste and the palm oil mill effluent. So that can be harnessed to produce green energy. Mini hydro, solar, we have plenty of solar panels now, so that is also a good thing. Solid waste, waste from the industry, and also domestic waste, kitchen waste, that can be used and to generate biogas, so that the biogas can be used to generate electricity. Wind is not so much. There is some in Sabah now, but not so much here. Geothermal, also not so much. Waste and gases from agro-base. Agro-base means waste from the agriculture industry, which can be used to generate gases. Okay, so this is what we are focusing in Malaysia now. So the green technology was launched by the Ministry of KETA in 2009, and the main goal was to increase the renewable energy portion in our mix of energy production. As you saw the earlier slide, it's only 1%. So we want to increase that, and therefore the Green National Policy was launched in 2009. And these are the major area of focus that you see around the country. So a lot of work is done on biomass, then solar, and other enabling technologies. So these are the three key ones. Okay. And if you look at biofuel, that is one of the major green energy that we have, and we are actively producing it in Malaysia, especially Sime Darby. They are producing biodiesel and exporting it into European market. The only issue now is the price is a little bit high, but that's where we are quite ahead in terms of renewable energy. So if you look at this slide, it shows three different categories of source. The first one, we call it as first generation source. This is basically oilseed crops, grains, and sugar crops. So you can use these crops to generate energy. And we call that as first generation. Why we call it as first generation is because these crops are also food. So there is an issue of food versus fuel. So whether you want to grow something for the fuel or you want to grow something for the food. So that is known as first generation. So to avoid that conflict, then people start looking at the second generation. In second generation, we don't use agricultural food crops, we use agricultural residues, waste. So the issue of fuel versus food does not arise. And we also use trimmings from gardens and grass and trees and so on. That is the second generation. This also is not moving too fast because of limitation. And the current practice or the current issue that we are going to look at is the third generation. The third generation, if you look on top there, this is production of fuel from algae. Now algae is very interesting because algae, nobody uses it as a commercial food product and it grows very well and it's abundant. Only thing is technology is not up to the mark yet to produce enough fuel. So we're going to look at algae now. This is the first generation biofuels, as I mentioned just now. So I'm going to skip this. You can see the pros and cons. You can see simple, scalable, easily blended and so on with the fossil fuel. But the problem is because it's competing with the food. Okay. Second generation, which is the waste from the agricultural products, that also has issues. You can see there, same downfall as the first generation fuel, but at least less compared to the fuel versus food competition. So now we look at the third generation. Third generation resources is basically algae. And a lot of work in the last 10 years is being done, especially in US. NASA has launched this project in 1999. It was a secret project by NASA, and then they funded it up to 2009 or 2010. So they are working hard on this to generate fuel from algae. So we call this as a third generation fuel or biofuel. And we will look at some of the issues. You can see the slides here. That this is a kind of statement taken from this magazine. And they call it as trilemma. Not dilemma, but trilemma. So we just quote the statement by this Tillman in 2009 in a magazine of Science. He said that the search for beneficial biofuel should focus on sustainable biomass feedstock that neither competes with food, nor directly or indirectly causes land clearing, and that offers advantage in reducing greenhouse gases, that is the CO2. So if you have these three combinations, then you have got the best biofuel. So that is the goal that we want to go into. So NASA has been doing this for quite some time, and they have managed to use algae to produce biodiesel. So we will look at some of the issues here. This is another extract from National Geographic 2007. There is no magic bullet fuel crop that can solve our energy woes without harming the environment, says virtually every scientist studying the issue. But most say that algae comes close than any other plant. So algae is the future. They will be able to produce fuel that we require for the future generation. But issue is technology is not fully developed. So you can see some data here. So it has been estimated that there are 200 million species of algae. Out of that, a few million are important for fuel production. And we have over 50,000 species that have been studied. And these species that have been studied, they have very high content of oil. Okay, they have very high on this. So that's why they are interesting. Compared to other cells, they have very high content of oil, almost 50% content of oil. The issue is how to grow them fast, in large number, and how to extract the oil, and how to produce the diesel from that oil. So that is the issue. All that is technological barriers which we have to overcome. So you can do a comparison here between other crops and algae, you can see that the oil yield per hectare per year for algae is almost 20,000 liters of oil per hectare per year. And you will compare that, the closest rival is palm oil, which is about 5,000. So palm oil is a good crop because it has very high oil yield compared to any other oil-bearing crops. Okay? So that's why we are fortunate we got palm oil and we can have large quantity of oil production, oil palm. Okay? So algae, you can see, is almost 4 times larger. And in terms of land use, if you see the land use, palm oil is 2 meters square per kilogram of biodiesel produced. But for algae, it's only 0.5. So not only the production of oil is high, the land requirement is also low. And therefore, the efficiency or productivity is very high, almost four times higher than palm oil. So that's the attractive part about algae. So what are the factors required to grow the algae? So you can see very simple cell, very simple organism, very simple plant material. So you need light, definitely. The solar light is required. CO2 is required. Algae requires CO2, and that is a good thing. That is a good thing because all the CO2 that we generate will be taken up by this algae. So we reduce our CO2. At the same time, that will be converted into oil, and that oil can be used into our biodiesel. Okay. They require nitrate, so that's all. Very simple requirement. And of course, other factors is like temperature, pH, and agitation. So this is a requirement. So you can see that. That's how algae will grow. It become green. I'm sure you have seen this. So microalgae are fastest growing organism. Compared to anything, they are the fastest growing. They can complete entire growth cycle in few days. Compared to palm oil, which require 5 days, 5 years. 5 years before you can see the fruits. This is only few days. But of course, the quantity is small. That is a challenge. We have to increase the quantity. Under optimum growth condition, algae can produce up to 15,000 gallons of oil per acre per year. Okay, so this is some statistics about algae. And I already mentioned just now, algae contains very high quantity of oil. And it's a simple structure, so it only have oil, protein, and carbohydrate. Okay? So the oil part is very high. So that's why algae can produce more oxygen and oil per unit biomass than any other plants. So it can produce oil, and at the same time, it can also, it takes in CO2 and gives out oxygen. And the amount of oxygen given out is more than any other terrestrial plants. So that is advantage of algae. So again, why algae? Because it doesn't compete. We have seen that it doesn't compete with the first and the second generation. High yield per acre, contains no sulfur. That's also important. It doesn't have any sulfur, so it doesn't emit any toxic emission. Besides CO2, other emission that we have is sulfur dioxide, which is very toxic. But algae has no sulfur, so no CO2 emission when you burn this algae oil in your engine. Highly degradable, not toxic, does not require soil to grow because it grows in water, so you don't require any land. Adaptable anywhere and can emit CO2, that means can absorb CO2 from the environment. So this is some of the companies that have gone into this algae production. So you can see that they have large farms like that of algae. This is in US. So they grow under simple condition. The land can be any land because that is not important. What you need is the water, and the algae will grow, and the sunlight and the CO2. So easy to grow, produce oil. Oil can be then converted into biodiesel. You don't have to depend on the fossil fuel, and it's good for the earth because emission, as I said, no sulfur dioxide emission. Okay, you can see that CO2 that is absorbed, about 2 grams of CO2 per gram of algae. That is a very, very high amount of CO2 that is absorbed by only 1 gram of algae. So if you have big farms, you see the amount of CO2 that can be absorbed. And for comparison, we can see that a person produces 2.3 tons per year of CO2. A car produces 6 tons of CO2 per year. An acre of normal forest consumes 2 to 3 tons per year. Acre of oranges consume 1 to 2 tons. Typical farm consumes 2 tons. An acre of algae consumes 60 tons of CO2 per year. That is the difference between algae and other crops. Okay, this is just a diagram to show you how algae is cultivated in large scale. They use raised ponds, okay, simple ponds. You can also hang it up in plastic bags like this. It's a plastic containers like that, and you can grow inside that and just put it out in the sun so that they multiply. Or you can put it in plastic tubes like this. This is somewhere in Florida, big one, Hawaii. So then what do we do with this algae? What we do with this algae is, the algae that you have, we can use it to convert it into biodiesel, or we can also use the biomass, because it's a plant, it's a biomass. We can use it, we extract the oil, and then the remnant can be burned and produce some oil, okay, we call it as gas and so on. We can also use this biomass and put it into a digester and produce gas. We call biogas. Okay, so that is the things that we can do. And from the biogas, you can generate power. From the oil just now, also you can generate power. So this is algae right in the center now. You can have biodiesel as one of the end product. You can use it for conversion into biogas, and then you get power. You can use it to produce ethanol in fermentation. That ethanol also can be used to generate power. You can use it to give some beneficial products from algae, some vitamins and all that, that also can be used. Okay. So many uses of algae. But we are focusing on energy. Okay, we're focusing on energy. Okay, this is the energy that you can get from algae: biodiesel, ethanol, hydrogen, methane, biogas, and also jet fuel, jet quality. Because the algae is unique because their structure, the oil structure is very, very good. And when you produce the oil, it is as good as jet quality oil, very expensive oil. Okay, so what are the challenges in this algae industry to produce biofuel? Number one is, of course, the cultivation. You have to go large, you have to go very big, otherwise you don't see the scale. Then there is some problem in harvesting and dewatering, because when you go large, then how do you throw away the water and collect the thing? So that is, but it's not very difficult. The most difficult part is extraction and conversion to biodiesel. That is something that a lot of research is going on, how to simplify that process, and then of course developing co-products. So you can see here, this is the supercritical methanol method to produce biodiesel from algae oil. So this is a one-step production. That means you don't have to extract. Straight away, harvest the algae, throw away the water, just use it as wet as it is, and put it into supercritical methanol, and you'll get biodiesel. Okay, so of course, the way I say it is simple, but it takes a few steps. Okay. Then you can clean up, same thing again. This is a supercritical instrument that produces high pressure, high temperature. Right. And another way of doing it is using microwave. This also can be used. Instead of supercritical, you can use microwave. This is also a one-step process where you can convert the algae into biodiesel. And what is the future? In future, we need more research in algae as a fuel. More private and government investment is required, otherwise you cannot go forward. We need regulatory and statutory guidelines. We need the government to come up with policy that you have to enforce, saying that everybody have to go for X percentage of renewable, then these things will move. Okay? So in the world today, the status is there are about 50 companies actively working in this area to produce large amounts of algae and also oil. 45 universities are doing some R&D on this. And still at this research level, that means commercialization is still slow because of issues and also funding. Okay? So this is the status now, but it is expected to move forward. And some new R&D, this is something that we are also interested at the university, that we want to improve the growth of the algae by using electromagnetic wave. So we want to irradiate the algae with some electromagnetic wave, and with that we hope that the growth, just now you saw that it takes 2 to 3 days to grow, can we do it in hours? And there is a possibility, of course this is still research, there is possibility that probably we can do this in a couple of hours, if not at least in one day. Okay? And therefore the yield will increase. Okay? So this is one of the things that we can do. And finally, this is just a slide to give you some final thoughts. So if you read the first one, in the beginning, there were algae. This is prehistoric time, when the world first came out after the Big Bang. There were algae, but there was no oil. Then, from the algae came the oil, the fossil oil that we have today. Now, the algae are still there, but the oil is fast finishing. Okay? So in future, there will be no more oil once finished, but the algae will still be there. So what can we do? So now, it does not make sense to explore oil anymore because it's finished, but we still have the algae. So what we have to do now is we have to work on how to get oil from the algae by our own artificial method, rather than depending on the natural process. This natural process takes millions of years. This takes millions. We cannot wait for the next few million because it's finishing. We have finished the oil faster than the algae can produce new generation of oil. So we have to remove the algae from the environment and put it in some reactor and produce the oil. And that's how we can do it. All right, thank you. Yeah, if there is any question.
Any questions for Dr. Saifuddin? We have the mic, please.
My name is H.P. Lam. You mentioned that you can produce oil from algae at about 15,000 gallons per acre per year. Can you sort of compare how much at present it costs to produce that versus cost of biofuel, biodiesel? Where are we in terms of that? Okay, thank you.
Okay, recently there was a comparison, and someone have made this rough estimation that if the oil price today, the fossil oil price today, remains high, that is above $70 per barrel, then this is comparable. If the price goes below that, it won't work. But now, because it is still at R&D stage, there is a lot of external costs that are involved also. But once we go into commercial, chances are we may get it around 60 to 70 US dollar per barrel oil produced from algae. But if the oil price comes below that, then I don't think any company want to venture into that. So it will remain as a research piece for quite some time until all the oil is finished. Then people will start thinking again. Why all this work is being done now is because of that oil price. You know? Oil price goes up to 100 US. Now it's already 80 now. If it drops some more, then I think half the company will close their production. Right? So it's around 60 to 70 US.